let's understand what all the important topics within the framework of LangChain. What exactly is this? How is it connected? And why is it very famous? All the nitty-gritties of LangChain we are going to discuss now. So if you look at any of the large language model until now, like if we just do a quick recap of a large language model using the API of the large language model, we simply get the large language model and we declare it. Temperature means how much creative you want this large language model to be. If you give higher temperature, temperature varies between 0 to 1. Temperature is between 0 to 1. If you give higher temperature near to 1, that means it will try to create stuff on its own. Temperature is near to 0. It will try to give the factual information as it is most of the times. That means it will not be creative. So depending on your task, you may have to choose the temperature. For example, if you are asking factual information, if you have given a data set, in that data set, you are asking what is the average of a particular column. In that case, you have to give lower temperature. You want factual information. You don't want things to be made up. But if you're asking this question, write a 4-line poem on AI. Now here temperature has to be high or low. Tell me, do you want the large language model to give whatever it has seen earlier, or do you want it to create new stuff here? We want it to be somewhat inventive here. So that is why we keep the higher temperature. Now you have to choose this based on your requirement. When you are in doubt, if you do not know what should be the temperature, always try to give near to 0, because most of the times we want to get the factual information out of it. Okay, but if you feel that there is an option for you to, like, if there's a requirement for you to increase the randomness, for there is a requirement for you to make it more creative, if you want this large language model to create new words or new stuff, in that case you can give higher temperature. So let's go back to the code file, quickly redo whatever we have done earlier using the large language model. This is the code file. As usual, I'm pasting the code file in the chat window. This code file will be given to you again in the documents wherever we are uploading. So install the packages. There are several packages that we will be using during this particular session. So install all those packages. Now you have to get OpenAI key. So in Google, you can store all the keys here in the secrets. So in Google Colab over here, so either you can write the direct key here directly, you can put your key here, that is also fine. Otherwise, you can keep it in the secrets if you don't want the rest of the world to see. Like, for example, I am presenting my Colab notebook right now to you. If I put my key here, you may get to see that key. If you don't want that, then usually in most of the Visual Studio or even Jupyter Notebook, you have this secrets option where you store all the keys in .environment file or some other file, and then you can use this option to get the key. Most of you may not have OpenAI key. OpenAI key is chargeable. So they are going to charge, I think, $10 for 15 million tokens. So you can ignore that OpenAI key, but you can get the Cohere key. All of you must be having Cohere key. So you go here, you add an extra item in this one, an extra field, which is Cohere key. So you try to make it as Cohere key, Cohere, and it has to be exactly like this, Cohere API key. And then you have to put the value here. Okay. You can actually make it visible and put the Cohere key here. Make sure that you are copy pasting that Cohere key. Once it is done, that's it. So once you have the Cohere key, then we will be using Cohere model for rest of the exercises. OpenAI is one of the best one right now in the market. This will give you the most accurate results. The next open source, one of the best open source is Cohere that I found. But I think 2 days back, Claude has released Sonnet 3. Everybody is talking about it. You will tend to hear these kind of news. Maybe every week on week or month on month, you are going to see something that is beating already existing ones. So maybe in future, after an year or so, OpenAI, Cohere, all of these would be back. Maybe there would be some model that is doing much, much better than all this. Okay. So I have got the files. So here it says grant access. Grant access means I have given the key here. Once I say get the key, I have to grant access for this notebook to access these values. So I have granted access for these 3 keys. For you, when you click on the keys, you may not see this. When you click on the keys, can you see all these keys being included, or is it blank or empty when you click on the keys in your system? Blank. So what you need to do is you have to do exactly, the name has to be exactly like this. It has to be in uppercase. This underscore should be exactly like this. So the environmental variable is this one, OpenAI API key. OpenAI API key, you can ignore this particular one. You may not have that, but Hugging Face, we can do it later. this one, Cohere API key, this is the important one. Make sure that you put your Cohere API key. Out of these three, if you put these last one, ignore these two, put the last one, that should do. So I'll do it one with OpenAI, then the remaining ones, we will do it with Cohere. So focus on this, everyone. So we will say from LangChain LLMs import OpenAI. And then I'm saying temperature is little high, LLM OpenAI. Let me call this as simply LLM only. My large language model is equal to OpenAI. Here I'm keeping slightly higher temperature. Let me keep it like the temperature is 0.9 because I wanted to create a poem. So poem, it has to be something new. My response is equal to llm.invoke, and then you write your prompt here. This is a prompt. And then if you try to print the response, it is giving me a deprecation warning. But once it gives an error, then only we will try to take it seriously. Even with this warning, you will get the output. In our world of tech and speed, artificial intelligence, we feed, it learns, it grows, it evolves, but it can truly feel and solve. So this is a poem. That is OpenAI. Now, if you do it with the open source model, which is Cohere, so you will say from LangChain import Cohere. In fact, you can also write two times here. Like you can say OpenAI, like if you have OpenAI, comma Cohere, that is also fine. In one go, if you're importing multiple models or Cohere, that is also fine. And then say my large language model is equal to Cohere. You can mention the model within Cohere, within OpenAI, there are several models that are available. Okay. So here it is suggesting the model is command X large. Otherwise, if you leave it, the best model, whatever is the default model will be taken. So I don't care about the model, but I do care about the temperature. So I will give temperature as 0.9. Max tokens is a optional one. I'll not give that. Temperature is 0.9. And then llm.invoke, write a 4-line poem on AI. So this is a poem that has been written by Cohere. The reason why we have to get this Hugging Face API token is you can also get a model from Hugging Face. In our last session, we have seen how to get the model from Hugging Face and fine tune it on our own. But as an API also, you can use the model from Hugging Face. For example, if you want to use Mistral model, okay. So you will say this is from Hugging Face models. Here you have to mention the repo ID. What is the repo ID in Hugging Face models? Let's say if I'm saying Mistral model, that is also one of the model. Okay. This is one of the Mistral model, which has around 22 billion parameters. Too huge, too huge. So this is called repo ID. So you can copy that repo ID. So my repo underscore ID is equal to Mistral hyphen. So let me get this. Yeah, Mistral 7X. This one is one of the model. Let us see what are its properties. What is it used for? This is the one. It is used for text generation. And this is a gated model. A gated model, you need to get the access. The transformer tokenizer might give incorrect results as it has not been tested by Mistral team. Anyway, they have given one note, but the rest of the ones, like all this, like you can use it for text generation, you can use it in chatbots, etc. So this is a repo ID that I can copy and I can paste it here. And then, is there any change? Looks like there is a slight change. Anyway, I'll take this model. And then the way you should use it is my large language model is equal to, you say Hugging Face Hub, whatever is the repository ID, and model crocs keyword arguments. This is a keyword argument. Keyword is temperature. The number is 0.9. Max length 256. It's optional. If you want to give, you can give it. Otherwise, you can leave it. Again, if I say my response is this, write a 4-line poem on this one. This is the one. So this is free. Mistral is also free. Hugging Face models anyway free. Cohere is, but free doesn't mean you will get directly. You have to get access. I think for getting the access, I think it may take 5 minutes, 1 hour, 2 hours. In some cases, just by accepting their terms, you will get the access. Okay. In not every case, you will get the access quickly. Okay. So these are the large language models that we have seen. If there is a chance for you, if you want to learn seriously, if you're really serious about large language models and the Gen AI, I would suggest you to get the OpenAI API key. So OpenAI API key. There is a place called platform.openai.com. If you go there, you log in to it. Once you log in there, then you will be able to get the API keys. You can create a new secret key. However, that is paid. If you see the usage, let's say if you see my whole of June, like it's quite cheap. As I told you, you can use it 15,000 times. You can use OpenAI. If you pay $10, you can roughly use it 15,000 times. Let's say later on, if you're doing very large applications, at least you can use it for 1,000 times. 1,000 times is too much. When you are going through my course, you may have to use OpenAI maybe 200 to 300 times. If you do multiple experiments, maybe 400 times. If you are doing like extensively, maybe 500 times or 800 times. 1,000 times $10 is sufficient, and for you to get all the results in all the exercises and the assignments multiple times, you can do it with OpenAI API key. Okay, so if you feel there is a need for it, if you feel that you're going to get good results with OpenAI key, you must get that OpenAI API key. I can say that this is one of the best model right now. Whatever are the large language models that are available, this has the highest accuracy, most relevant results we are getting with OpenAI. Other models are working, but they are not as good as OpenAI. Now, this is how large language models work. But what is the problem with the large language models? Can I use a large language model directly in my application? Let us suppose I'm solving a problem. Can I directly take this large language model, use it in my application? The large language models have some inherent issues. What is the first issue? Let us suppose my company has some specific private documents. Do you think large language model can access those specific private documents information on its own? Directly it will not be able to access. It was built on a whole internet of data, generally available data, but specific private documents it cannot understand. My particular company has some contextual nuances. That means my particular company is related to, let's say, automobile. Within automobile, I'm talking about a particular section. Within that, I'm talking about a particular sub team. Now that is very, very niche area. I cannot expect a large language model to work with that particular problem statement effectively. And the most important issue is they do not have up-to-date information. For example, if I ask a large language model, okay, let's say my large language model is equal to Cohere. I have already defined it. Once again, I am defining it here. My large language model is Cohere. And then here, this time I'm asking, what is the stock price or the current market price of Apple stock? Do you think we are going to get the current market price of Apple stock right now? What do you think? It says Cohere model, it will say that, you know what, I have been trained like as an AI access model. I have no access to financial markets, the ability to real time, etc., etc. All this it is not able to tell. For example, if I change my model, if I say my large language model is OpenAI, even if I take a good large language model and temperature, I want to keep it like here, it's good to keep temperature 0, isn't it? Why am I keeping temperature 0 here? Tell me. Earlier also, I should have kept temperature as 0 only. What's the reason? When I'm asking for the current market price of Apple stock, do I want this large language model to be very creative, innovative, and give me some kind of very make-up results or made-up values, or we want the factual information? If you want the factual information, keep the temperature very near to 0. Factual information you'll get. So if I take OpenAI as a large language model, what does it say? It says as of September 2021. So the model that we are using has been trained. The latest information that it has got is as of September 2021, 3 years back information. The current market price of Apple stock is obviously September 2021. At that time, current market price was given. But if I use some other package, let's say if I use Yahoo Finance, Yahoo Finance is a package that gives us the market related information. So how do you get the current Apple stock price? Apple stock price ticker name is APPL, and then the current Apple stock price is somewhere around, as of today, it is 207.49, whereas it is saying 148 per share. Now, how do you build a financial related application where you combine this Yahoo Finance information with the large language model? How do you connect this external data, external world data to the large language model? Large language model have immense capability in terms of interpretation, immense capability in terms of reasoning. But do they have access to every piece of data that you have? Do they have access to your current information? Do you think large language models have access to your private documents? They don't. So how can we create customized applications, very lengthy applications, which are working to solve our problems using these large language models? For that, we need a framework. LangChain is a framework. LangChain is a framework that will connect large language models to our private data, and we can create applications. Working with large language models is made easy by LangChain framework. First of all, what is a framework? In most of the like it is a kind of software development term, framework. A framework is almost like a collection of several packages, a collection of several functions, or collection of several toolboxes that will make our life easy when we are working on a particular problem statement. When you are working with large language models, LangChain framework will automatically give you, when you go to LangChain, it will automatically give you so many pre-written codes, so many pre-written tools that will make your whole development much, much faster. If you want to develop very fast every application, then you must use a framework. Through framework, without framework also you can develop, but it will be much slower and there will be very much customized code. Let us suppose if there is no framework for Hugging Face Hub, you have to write a different code. For Cohere, you have to write a different code. For OpenAI, you have to write a different code, whatever is the code rule that OpenAI has given. But if you are using a LangChain framework, then from LangChain, I'm importing LLMs. From there, I'm importing Cohere. That means if you write this code automatically, LangChain framework has created whatever is the customized code that is good for Cohere. Here, LangChain has created the customized code, whatever suits for Hugging Face Hub, whatever is the customized code that is suited for OpenAI, it has been created by LangChain framework itself. So what is a framework? Imagine that, let's suppose you want to create a toy car. Without the framework, you have to create that toy car from the scratch. Let us suppose if I'm giving you a framework, what is the framework? I want you to create a toy car, but what I have given you is, I have given you the wheels, I have given you the axles, I have given you the body, I have given you the doors. Now that is a framework. Now there is an advantage with the framework, there is a disadvantage. What is the advantage? You can create that car quickly. But what is the disadvantage? There are rules set. If you want to make some changes to the doors, if you want to make some changes to the wheels, that you cannot do. So framework is used for building these software applications quickly. For example, few years back, if you want to create an application, mobile application in Android, if you want to create a mobile application in iOS, you have to write two different pieces of code. But if you use Flutter framework, what you can do is you can write the code once in Flutter, automatically you can export it, which will be feasible in Android, automatically you can export it, which will be feasible in iOS. I think a lot of frameworks you might have heard already, React, Angular, these are all the web development frameworks. Even in Python, there is something called Django framework. Have you heard of it? Django framework. I think Flask is another framework. So these are all the frameworks. A framework is a toolbox that makes your life easy if you want to create something very quickly. Okay. So you can imagine, when I say a framework, you can imagine that as there is a lot of libraries, there's a set of pre-written codes, okay, software tools that will help you to execute very, very quickly. So what does LangChain contain? What are the main components of LangChain? There are three main components: a prompt template, an LLM model, and a chain. Prompt template, LLM model, and a chain. There are several other components as well, something like retrieval, agents, tools, memory. These are also components. But slowly, one by one, I'll introduce them to you. Otherwise, directly, if we jump onto this, it will be very much overwhelming. To make this easy, what we will do is we will start with the basic components first. In LangChain, you have components like a prompt template, a large language model, and a chain. Let us see how it works. Let us suppose if I'm writing from LangChain, import OpenAI. You don't need to do that again and again, but here I'm writing so that we can get used to this. And then you mention your large language model. Here I'm mentioning it OpenAI, but if I want to use it as Cohere, I will say my large language model is equal to Cohere, whatever is the temperature. Okay. As of now, I would like to use OpenAI in this example. And then I would say my large language model dot invoke. So until now, the way we have written the prompt is we have directly given whatever is our input prompt in this LLM dot invoke. Okay. And LangChain has, or the large language model has given us the output. This is known as open-ended prompt. What is the problem with open-ended prompt? I have written the code like this: write a 4-line poem on AI. There is no way that everybody in this world will be writing the same prompt like this. Maybe if I tell 10 people that you have to get a good poem on AI, not everyone will be writing the same prompt. Some people may write that, let's say, LLM dot invoke. Somebody may write that, what is the, write a 4-line poem on AI, or somebody may write like craft a great poem on AI, or craft a creative poem on AI, right? This could be one prompt. Somebody else may write that, write a poem on AI, write a 4-line poem on AI, but in simple terms, for kids, suitable for kids. This is what somebody else has written. Somebody might write it in complex words like that. You can write it in any manner. Some people will write like, if you do not mention how many lines it is required to write, maybe it may give some other result here. So I said craft a poem on AI. So let me print the output. So every time I'm executing it, I'm consuming few tokens. So right now, earlier it was 4-line poem, but now since I haven't mentioned exactly how many lines, so it is giving in this manner. You remember we had one session on prompt engineering where we understood how do you interact, how do you communicate with the large language model. Prompting is one of the greatest skill one should have. But when you are building large applications, how do you control the prompt of the user? User can give any prompt. You might have built a great application, but the kind of prompt that the user has given, maybe it may be changing the way the output is appearing. So these are all called open-ended prompts. So what you can do is you can kind of make all these forms uniform by using a prompt template. You can use a template that will make sure that every user, like your application, you want it to do in a certain manner. Your application finally has to give the output in a particular manner. But by giving a different prompt, user may get a different result. How do you make sure that every user sees the same output? How do you eliminate this randomness from user to user? By giving a prompt template. Template is a keyword here. So you can create a template. You can restrict what the user is giving. Let's say write a 4-line poem is what your actual restriction that you want to keep. And then this you can give the freedom, whether he wants to write it on AI, whether he wants to write it on data science, whether he want to write it on a pen, whether he want to write it on a teacher's day, whatever is a poem. I write a 4-line poem on earth. So you want to make the user to change only the word, but the remaining one you want to keep control. So you have to create a template for that. So prompt template will make sure that the user is not writing anything waywardly. So the first concept in LangChain is prompt template. So we have to say from LangChain import prompt template, prompt template. Let's say now my template is write a 4-line poem on the subject. Now this is a variable, subject name is a variable. So user can give subject name as the input. Then after that, once I mention this template, my template is write a 4-line poem on the subject. What is the subject name? This I haven't mentioned. The user is going to mention. So if the user mentions data science here, write a 4-line poem on the subject data science. Write a 4-line poem on the subject earth. Write a 4-line poem on the subject Father's Day. Write a 4-line poem on the subject a teacher. So everything, every prompt that we are writing, everywhere the output will be exactly 4 lines. So once you create this template, then you have to create something called prompt. Then prompt template is the function, input variable is subject name, template is the template. And then you will say, so finally what will happen if you say data science? This will be the final prompt, write a 4-line poem on data science. Let's say if I try to say, I don't want it on data science. Let's say if I want it on Father's Day. So what will be the output in all these cases? Write a 4-line poem on the subject data science. Write a 4-line poem on the subject Father's Day. Write a 4-line poem on the subject solar system. You are not really giving a lot of freedom for the user, and you're doing it intentionally because prompt is a critical part in a large language model. And you want to give instruction to a large language model in a particular manner, but you also want to give some, you also want to take some input from the user. The user should not give the complete prompt. There is something called prompt ingestion. What that will do, user will give such prompts that will take all our private data. User will give such prompts that will kind of delete some of our data, or he will access some private information that he should not be accessing. To avoid all that, we have to write a prompt template in such a way that the user doesn't have a lot of freedom. Max to max, what he can do is he can put the word that he requires. Then on top of it, this prompt template will create this prompt. So once you have the prompt template, we already have the large language model. So in a basic chain, one of the first form of the chain that we are discussing, a chain has 3 components: a prompt template. We will see multiple examples of this. I just introduced to you prompt template, a template where we will write the prompt and we will take one variable from the user, and a large language model. We have seen what is a large language model. This template will be given to the large language model, and a chain. A chain will connect these two. So LangChain, they have come up with this idea of connecting various inputs or connecting various instructions. They have named it as chain. Okay. So let us see one example of that, a chain example. Then I will pause and take some questions from you. So once you create these prompt templates, now we will write everything from scratch once again. So from LangChain, dot LLMs. First, like I have already written this, but I'm rewriting this just to get familiarity so that if you observe it multiple times automatically, we will be able to remember it for a long time. First, I have got my large language model. Then I got my prompt template. Then LLM chain. First time I'm introducing something called LLM chain. Once you import all this, you have to. So what is the first thing? You have to give the large language model. So my large language model is equal to OpenAI temperature. Now here we are talking about writing a poem or something, then temperature will be high. If you're talking about something factual information, then temperature should be low. Otherwise, if you do not have any idea on what should be the temperature, just leave it. I think default value of the temperature is 0. In some models, in some cases, the default value of temperature is 0.5. If you want to be very strict, make always, like when you're in doubt, keep the temperature as 0. That would be better. You will get the factual information. So once you have the large language model, then you define the template. My template is equal to list down the historically significant steps in the field of field name. I want to know what are the historically significant steps in machine learning. I want to know what are the historically significant steps in organic chemistry. What are the historically significant steps in computers, or what are the historically significant steps in quantum computing? If I want to know what are the historically significant steps in a field name, user can give only the field name. So I'll write the template, my prompt template, input variable is field name. This is the template. And then once you give the large language model, so this is one, this is, you write an LLM model. This is an LLM model, large language model, and then prompt template. And then finally, you combine them using a chain. So how do you write a chain? So I'll say my chain is equal to simply large language model dot, that is a large language model, and give your prompt, whatever is the prompt. Okay. Sometimes it may give, like, how do you invoke the results out of this chain? The chain is done. Now, finally, you have created the chain, you get the result. My result is equal to, you write chain dot invoke this time. So I want to know what are the historically significant steps in the field of machine learning. See, the input user is not thinking he is giving a prompt. He is giving a word. We are expecting only one word from the user, machine learning. And then whatever is the result. Within the result, I think there is one prompt and there is one text. Text is the actual output that we want to get. So if you execute it, sometimes it may give this deprecation warning. So LangChain, LLM chain is one of the old style. They are replacing that with this type of format. This is known as LangChain expression language. In future, maybe this will be used, or LangChain itself will be continued. We do not know. So this is the actual code that we have written, and this is the output. What are the historically significant events in the field of machine learning? Development of perceptron in 1957, introduction to decision trees in 1960s, backpropagation algorithm in 1974. Backpropagation algorithm came in 1974. But the thing is, nobody has developed it until 2006, 2007, 2006, 2007, or probably 2015 is the time when backpropagation totally became a very big, talking point, because we have the computation machines, support vector machines in 1992, MNIST data 1998, and the random forest, etc., etc. I think we may have hit the max tokens. Let me say my max tokens is equal to, let's say, I would take that as 2000. I think max 4000 tokens are allowed in OpenAI, and taking max tokens equal to 2000. I wanted to get all the, I would have given historically 10 historically significant steps. It is giving by default 10 historically. So in 2016, AlphaGo, since the model cannot access the recent ones, it would have even given large language models. In machine learning is also generative adversarial networks, neural network processing, etc., etc. These are all the top 10 historically significant events in there. So you have a large language model, you have a prompt template, and then you have a chain. That is one of the examples of the basic chain. Execute this, all of you. While you are executing this, if you get any questions, please let me know.
So I have one question, sir.
Yeah, please go.
So when we talk about the open-ended prompt, if two person at two different places gives same prompt, what is the probability of getting the same answer out of the answer?
If the question that they are posting is kind of retrieving a factual information, for example, you have written that give me the equations for theory of relativity, okay, in like whatever equations are, I think there are 20 equations, so list down all the 20 equations of theory of relativity. That is prompt one. And then someone else also written that list down the, like, ignore theory of relativity. Let's say back propagation we have discussed, right? So give the equations for back propagation and weight calculation in artificial neural networks. So that is what you have written. Give me the equation. Somebody else also has written, write the back propagation algorithm and mention all the equations. Both of them will get the same equations. Maybe the display would be different. Maybe it will start with a different description here. It will start with a different description here. It will end with a different conclusion here. It will end with a different conclusion here. But both of these equations won't change. Okay. But if we are talking about, now these are fixed set of information. This is fixed information. The theory behind back propagation, the equations are fixed. There is no way large language model can tweak them. So in this case, you will get the same result. But if we are talking about something that is not fixed, so for me, like for a large language model, this historically significant steps, I may get this answer, but if somebody else executes what are the historically significant steps, they may get a slightly different answer, because there is no place where the whole world has accepted, like this is proved, the whole world has accepted that these are the equations, we must get these equations only. But if you're talking about historically significant steps, now there is a probability that maybe these 10 could be the historically significant steps, or there could be something else. So at the end of the day, a large language model is generating the next word in the sequence. When it is generating, let's say it has generated these words, for example, tokens. So it has generated these tokens in the sequence. Now, when it is coming to the next token, introduction of decision tree, sometimes what happens is there are 4 or 5 tokens which are having the same probability. So I can choose this one or this one or this one or this one. All of them have the same probability. So it will choose any one of them based on that. So maybe for me, it is coming as decision trees. For someone else, it may come as something else. R.A. Fisher, who introduced regression, that could be another event. Okay. Or somebody introduced probability, that could be another event, because all of them are equal probabilities. Are you getting what I'm trying to say? So 2 people giving the same prompt may not get the same result if it is related to a subjective matter where there is no fixed output. If it is related to a subjective matter where there is absolutely fixed output, then they will get the same result.
Yes, sir. And think this means in the subjective matter, we cannot we can trust the accuracy of the model, but it might vary from place to place.
Yeah, because there is no way I can tell the model that this is right or this is wrong. Okay. So, but we can tweak the model. Like if we get the output, there are some ways we can tell the model, do not look at the whole set of data. I'm going to pass on certain documents to you. Please look at those documents and make sure that you limit yourself to those documents and give me the output. So that we can do. So there are some ways to tackle it, which are coming up later on. Okay. There is something called retrieval augmentation, which means I'm giving my documents. Okay. Don't look at the whole world of data, get your answers only from these documents. There we can expect 2 people to get similar information, because we are limiting its sources into one document only, or a set of documents only. All right. Let's go back to this one. So this is, on the face of it, it is a very simple procedure. You declare an LLM model, and then you declare a prompt template, and then you create a chain. Here, this is very simple. Later on, several other components will come in the chain one by one, one by one. Later on, I'll introduce memory in this chain. Later on, we will get into RAG. Later on, we will get into agents. So one by one, we will introduce more and more components in these chains. These chains will get very, very complex. But before that, if we go in this manner, one by one, like the most simplest form of the chain, once you understand this, the remaining ones slowly we will, increase the complexity one by one. Let us do one more example of the chain. So once again, I will declare my LLM. Usually, it's not the case that every time you have to declare the LLM like this. Usually, when you're developing some applications, right at the beginning, you mention what is your LLM. But what I'm thinking is sometimes you want your large language model to be a little bit creative in bits and pieces, then you can redeclare the LLM. But here, for the sake of memorizing it, I'm declaring it multiple times. I'm declaring my LLM OpenAI. This time, I want my LLM to be very creative, so I will keep the temperature as 1, as maximum creative as possible. So I have declared my large language model. Now I'm declaring my template. I want to make all these concepts easy for anybody. Anybody who takes a concept, I want to make it easy for them. So that is the requirement. So the topic name is topic. Explain this topic to a 10 years old kid, or explain this topic to a layman, explain this topic to a beginner. So we take any topic, we want to make it easy for our understanding. Okay. So this is the template. Once you give the template, so you have the large language model, you have the prompt template, and then the chain. You just write your large language model and then the prompt. And then finally you say my result is equal to, you have to say chain dot invoke. Let's say logistic regression is something that I want to explain it to a 10 years old kid. How do I do that? So logistic regression is like a game, etc., etc. This sometimes when we say 10 years old kid, it gives too much childish. So we will say explain this topic to a layman. Logistic regression, even if we're doing spelling mistakes, it is perfectly fine. This large language model in the prompt, if sometimes if in the prompt, if you're not giving the right spelling, that is still fine. It will be able to understand what we are doing. Okay. So logistic regression is a statistical method used to predict the knowledge of the event, etc., etc., etc. This one. And then you see this output, this is fine or not. And then let's say something like artificial neural networks. So it comes as the topic name is artificial neural networks. Explain this topic to a layman. Artificial neural networks are computers, mimic the way human brain information, just like how brains, etc., etc., etc. All this information is given. This is a basic form of a chain, a large language model chain. I think this LLM chain, slowly we are getting an error in some cases that this LLM chain may go away. They are creating this LangChain community. They are creating something called LangChain expression language, LECL, LangChain, LCEL, LangChain expression language, LCEL. So this LLM chain is actual function. Instead of giving that, the way we have to give it here is, let's say chain one, new chain I'm defining, is equal to, you have to give it in this manner. You have to give the prompt and then a pipe and then LLM. That's it. So prompt is your prompt and then a pipe, whatever is your large language model. And then we will say chain one dot invoke and then we will get the result. There must be the string. I think the result will be slightly different. I'll try to directly print the result. So this is a result that we are getting directly. There is no, earlier it used to be result text and it used to be a dictionary where we have to get the text. Directly the result is printed in this one. Probably in future, this would be the code LangChain expression language, or maybe both of them will be the code, because this is a little confusing. This is a little bit a kind of not that intuitive. So they have recently introduced this LangChain expression language, but that if they get into this, then this whole point of LangChain itself is to make things simple. Now this is making a kind of this code little complex. People may not accept it. Then people may lose interest in this LangChain framework. Okay. As of now, this is working. We will stick to it. In future, if you have to move away from this, then maybe LangChain expression language, the same thing. We have to write it differently. That's what we may have to use. Okay.